Hello guys, my name is Jon Alfredo and today I'm going to show you my physics project. The program I've used to do it is called Geogebra, which is an extremely helpful tool to teach. First of all, I want to mention that this project is all about a car going fast on a straight road or circuit, but the issue is that 200 meters away there's a turn with a particular banking angle and radius. Apart from that, we should also take into account what the weather is like and the tires that the car is running at the moment, so as not to get out of the road while getting through the turn. So basically we have to calculate the highest speed at which the car can turn without skidding and getting off the track. Well, moving on to the problem, here we have that a 1200 kilogram race car is being driven on a circuit and is about to start a turn with a 50-meter long radius that we can see here. The friction coefficient between the brand new Michelin tires and the dry road is 1. So let's stop and I will explain you this a little bit. The 50-meter long radius of the turn, we can easily change it by moving this. So as we can see here down below, the radius of the turn is changing. Now, the friction coefficient between the brand new Michelin tires and the dry road is 1. On this chart, we can see the different friction coefficients that we can find by combining the different weather situations and the different tires that we run onto our car. So the road can be dry, wet, there could be heavy rains, puddles or ice, and depending on the tire brand, Michelin, Goodyear, Pirelli, and if they are brand new or they are already used, we have different friction coefficients. So if we have a 1 friction coefficient, this means that we are using our Michelin tires and the road is dry, so the sun is shining. If we move this, we can see that the speed here is moving because the friction coefficient is different, but the sun is still shining because until we don't get to the 0.65 the weather is not gonna be, the road is not going to be wet. So once we move to the 0.65 we can see there are some clouds and it's raining, so the road is wet. If we move it more, on 0.5 we have more rain, heavy rain. Same happens with the puddles if we keep on moving it, and finally if we get to the 0.1 friction coefficient there is ice on the road because it is snowing. Okay, so calculate the maximum speed the car can have without skidding and getting out of the track. The angle of banking is 15 degrees. Okay, the angle of banking in any road is basically the angle between the road and the x-axis. So if we change the angle of banking, we can see that the road is moving because the angle is getting bigger or smaller. Okay, so now let's move to the calculations. Here we can see the different variables of the problem, which are the angle, the radius, the mass, and the weather, which are basically just making reference to the friction coefficient. Finally, we get to the speed formula. And something very important here is that the mass is not a dependent variable. This means, I will show you here, that, for example, if we change the weather, we can see here down below that the speed, the maximum speed that we can have, is continually moving. Same happens with the radius. And with the angle of banking. But on the other hand, if we move the mass of the vehicle, nothing happens on the speed. The speed is still the same. That's what I mean by saying that the maximum speed in the formula does not depend on the mass. So that's basically all my program. I hope you've enjoyed it. Thank you for watching. See you. Bye.